In the previous video, I left you thinking about how many circles are needed to rotate into vertical polarization, for example. And if we have the initial state of, let's say, pure horizontal polarization, like 0 degrees, then it would take, if we rotate each cycle by 1 degree, it would take 90 cycles to rotate by 90 degrees. Yes, and after 90 cycles, we can measure those 90 cycles. We can be sure that the photon will be in vertical polarization. Now an interesting moment. Let's imagine we start with the horizontally polarized photon, totally is like 0 degrees, and we have this setup. But now, instead of having an empty interferometer, we put inside a brick wall. Again, brick wall is inside in one of the arms. What happens? It's important which arm we have put the brick wall into. We recall this is horizontal arm, this is vertical arm, vertical, horizontal. And initially we have photon that goes almost totally through this arm and goes out purely horizontally polarized. Then it gets rotated by 1 degree, and it has a 1 degree polarization plus 1 degree. So it has a next run, second run, it has a small probability of going through here. And therefore a small probability, let's say 1% chance of hitting the wall. But it has a much larger probability, I'll draw it in a large dashed line, 99%, of just freely going through the horizontally polarized arm of the interferometer. And here is where our knowledge comes together from the Zeno effect. Essentially, what the wall does is measures the state in which the photon is. But it measures it in such a way that it does disturb it, but it doesn't destroy the photon, because there's so few of the photon coming to the wall that essentially the wall is performing the Zeno effect. It resets the wave function of the photon back into totally horizontally polarized, 0 degrees polarized. Yes, we have lost this part, this arm of the photon, and we're left with 99% probability. Of course, there is some chance that the photon will be lost to the wall, but with an overwhelmingly large probability, we are left with a photon that has whose rotation has been undone. Yes, it was rotated just a little bit, and now the rotation is undone. Just a little bit, now it's undone. And if we have a brick wall in the middle, and we make, again, same 90 cycles through the interferometer, then what do you expect to see here after 90 cycles? What photon polarization do you expect here after 90 cycles? I remind you that after 90 cycles with empty interferometer, we expect totally vertical polarization, like plus 90 degree polarization. What about this case? And yes, that's true. After 90 cycles, you expect absolutely horizontal polarization, 0 degree polarization. We're almost there. We're almost came up the way of seeing, like being able to measure something without interaction with higher than 50% fidelity. And how to do it, we will see the next time.